Have you ever heard of the Oort Cloud? It's this massive cosmic thing people say is like a cage around our solar system, trapping us forever. Well, guess what? That's a myth. Let's set the record straight. Welcome back to our universe exploring channel. Today, we're diving headfirst into the enigmatic Oort Cloud. No time to waste. So what's the deal with this not-so-cagey cloud? The Oort Cloud is a somewhat mysterious shell of icy objects that surrounds our solar system and is the source of most of the comets we see in the sky. You may have heard of the Oort Cloud as a barrier or a cage that prevents us from ever leaving the solar system and exploring other stars. You may have also heard that it's very dense and dangerous, full of rocks and ice that could smash any spacecraft that tries to pass through it. Well, I'm here to tell you that these are all myths, and the reality is much more fascinating and complex. The Oort Cloud is not a solid wall or a fence that blocks our way out of the solar system. It is actually a very thin and sparse layer of icy objects that orbit the Sun at a very great distance, far beyond the planets and even beyond the Kuiper Belt, which is another region of small bodies beyond Neptune. The Oort Cloud is so far away that it is not affected by the gravity of the planets, but only by the gravity of the Sun and other nearby stars. The Oort Cloud is also not a single structure or a shape, but rather a spherical shell that has two parts, an inner part called the Hills Cloud and an outer part called the Oort Cloud proper. The Hills Cloud is closer to the Sun, between 2,000 and 20,000 astronomical units away. 1 AU is the distance between Earth and the Sun, which is about 150 million kilometers or 93 million miles. The Oort Cloud proper is farther away, between 20,000 and 100,000 astronomical units from the Sun. To give you some perspective, Pluto's orbit is only about 40 astronomical units from the Sun, and Voyager 1, the farthest human-made object from Earth, is only about 160 astronomical units from the Sun, as of 2023. The Oort Cloud contains billions or even trillions of icy objects. They are mostly made of water, ammonia, methane, and other frozen gases. These objects are very small compared to the planets or moons, ranging from a few kilometers to a few hundred kilometers in diameter. They're also very far apart from each other, with an average distance of tens of millions of kilometers. This means that there is plenty of empty space in the Oort Cloud for a spacecraft to fly through without hitting anything. However, this does not mean that traveling through the Oort Cloud is easy or fast. The main problem is not the density or danger of the Oort Cloud, but its enormous size and distance from us. The Oort Cloud is so huge that it would take hundreds or even thousands of years for a spacecraft at the speed of Voyager 1 to cross it at current speeds. For example, Voyager 1 is traveling at about 17 kilometers per second or 38,000 miles per hour relative to the Sun, which is faster than any other spacecraft we have launched so far. But even at this speed, it would take Voyager 1 about 300 years to reach the inner edge of the Oort Cloud, and another 30,000 years to reach the outer edge of the Oort Cloud. That's longer than all of human history. So why do we care about the Oort Cloud if it's so far away and hard to reach? Well, because it's one of the most mysterious and intriguing regions of our solar system, and it holds many clues about its origin and evolution. The Oort Cloud is believed to be a remnant of the primordial disk of gas and dust that formed around the Sun when it was born about 4.6 billion years ago. Some of this material condensed into planets and moons in the inner solar system, while some was scattered into the outer solar system by gravitational interactions with giant planets like Jupiter and Saturn. Some of these scattered objects ended up in stable orbits in the Kuiper Belt, while others were ejected into very long and elliptical orbits that formed the Oort Cloud. The objects in the Oort Cloud are therefore some of the oldest and most pristine in our solar system, preserving information about its early history and composition. They're also very sensitive to external influences such as passing stars or galactic tides, which can perturb their orbits and send them plunging towards the inner solar system as long-period comets. These comets are spectacular visitors that can be seen from Earth with their bright tails and glowing nuclei. Some famous examples are Halley's Comet, Hale-Bopp Comet, and Comet Neowise, which I myself had the pleasure of taking a picture with my own camera. By studying these comets and their origin in the Oort Cloud, we can learn more about our solar system's past and future, as well as its place in our galaxy and beyond. We can also test our theories and models of how the Oort Cloud formed and evolved, and how it interacts with other stars and the interstellar medium. The Oort Cloud is therefore not a barrier or a cage, but a gateway and a treasure trove of scientific discoveries. I hope you enjoyed this video and learned something new about the Oort Cloud. If you did, please give it a thumbs up and follow for more videos like this. If you have any questions or comments, feel free to leave them below. Thanks for watching, keep looking up, and see you next time.